Okay, so we were talking about the dipole-dipole interactions. Okay, so if we look at the periodic table here, we can have dipole-dipole interactions between molecules where we have covalent bonds. Okay, and for example, one of the common examples of dipole-dipole interactions is the case where we have a hydrogen with an electronegative atom different than FO or N. So, for example, you can have HCl, you can have HI or HBr, as you like. Any example can work. Okay. So let's say H with Br. So what will happen is that you will have always H when connected to another atom of group 7. Okay, since the two electrons of uh, H will be from one side of H. Okay, this will create a positive dipole. So I will have a positive dipole at H. Okay, in general, the notation we put, since uh, it's a charge, يعني, we put it as delta plus to, to put a difference between the ion and the dipole charge. Okay, so the dipole charge is symbolized as delta like this. Delta plus, okay, for H, and for the other atom, delta minus. Okay, and in this way, dipoles can form between negative dipole and positive dipole. And also, you can represent these dipole interactions by dot lines. Okay, so you have another molecule here, HBr, and this will be repeated because this can be repeated infinity of times. So you can have these types of dipole-dipole interactions between or H and Br or H and Cl or H and I. Also, you can have it between other, yani for example, between Cl and I. If you have between I and Cl and you want to represent the dipole form, okay, who will tell me which one will be the positive dipole, which one will be the negative dipole between I and Cl? So if I represent the molecule I with covalent bond, doing covalent bonding with Cl, okay, which will be the negative dipole, which will be the positive dipole in this molecule? To know this, I should compare the electronegativity of both. Okay, it's always the electronegativity increase in this direction and in this one. Okay, so it's clear that Cl is more electronegative than I atom. This is why when combining I with Cl, so I will have a positive dipole, delta plus, while Cl will constitute the negative dipole, delta minus. Okay, and in this case, what will happen is we will have uh, dipole-dipole interactions, okay, between Cl and I. So always the negative dipole will attract the positive one, and this can be repeated infinity of times. Okay, so this is how we can illustrate dipole-dipole interactions. And here I have another Cl that can connect with another I, etc. Okay. Now, if I just give you a final example, if I want to tell you what is the type of bonds between SH2 molecules. So if I ask you what is the type of bonds between SH2 molecules, I can say that it's in hydrogen bonding. No, because what is the condition for hydrogen bonding? H should be connected with F, O, or N. Okay, so In the example of CH2, it's similar to hydrogen bonding, but I don't call it hydrogen bonding. I call it dipole-dipole interactions because it's combining H with atom different than FO or N. And since we have covalent bonds between them, then this might create dipoles, positive and negative dipoles. And of course, here the positive dipole will be from the side of H, and the negative dipole will be from the side of S, because S has more electrons on its outer shell, so it will have ion pairs for him, which will create a negative dipole. And we have a positive dipole for H, since electrons are on one side of H. So if I want to illustrate dipole interactions for SH2 molecule, I will first draw one molecule SH2. So it's like H2O, same structure. Since S is of group 6, so it has 6 electrons on its outer orbit. Okay, so this is 1, 2, 3, 4. Okay, and the other two will be shared with 2 hydrogen atoms, which will create bonds, covalent bonds. So this is the first bond, this is the second one. So this is here H and H. Okay, and after this, what will happen is that I will have here, due to pair of ions, it will create on this side, will create a negative dipole. So here I have a delta minus. Okay, and for each atom of hydrogen, I have a delta plus. Okay, so what will happen here, that each H can connect to another S, and each S can connect to another H. Okay, so here, for example, I can have this. I have another S here from the electronegative side, and from this side, I will draw it like this. So this is S with delta minus here. So delta plus and delta minus will attract. These are the dipole charges. Okay, and I will have H and H from this side, of course. Also, this H, which has a positive dipole, can interact with another S. Okay, so this H can interact with another S, etc. So you will have a formation of a high number of molecules that interact with each other. Okay. Any question on this? So we are done with this chapter. Next time, hopefully, we start chapter C. Okay, thank you.